Over the last few months, I made 26 games, one for each letter of the alphabet from A to Z. The goal was to start off with simple 2D games and then gradually build up to a AAA quality game experience. So now that I'm finished with this crazy project, I wanted to share it with you all. I learned a lot and I hope that you're gonna learn a lot too. So for the first game, I wanted to do something a bit unconventional and write a game using the Rust programming language. Now this is an aircraft flight game called Aerial. Your goal is to dodge the obstacles. To mix it up a little bit, there are these laser things that will also kill you on impact. For every obstacle that you pass, your score increases. I heard a lot about Rust in terms of the safety and performance, so I figured, oh, that sounds like the perfect language for game development, right? Let's give that a shot. So Rust is a language that goes above and beyond to make sure that your code is correct and safe, almost to a detriment actually. Rust has something called the borrow checker, and it's basically in charge of checking your references to make sure that you're using them in a safe way. Unfortunately, I found that the borrow checker does more harm than good in the context of game development, and really slows down your momentum when you have specific data structures and behaviors that you want to implement. So yes, Rust is a safe language, but only if your program is 100% written in Rust. For rendering with OpenGL, I chose the SDL2 library, which is a C library. It helps with creating the window, handling rendering, input and audio, and it's all cross-platform. Now, even though we're writing the game logic in Rust, the underlying rendering code is written in C, which doesn't have the same level of compile time safety. I actually had a few situations where the Rust program compiled fine, but the program still crashed because the underlying C graphics library, but that doesn't mean I gave up on Rust. Actually, in a later project that I'll show you in this video, I chose the Bevy game engine framework, which made it a much smoother process. Nonetheless, for this first game, my first Rust game development experience, wasn't that great, but that's okay. We got 25 more games to go. So the next game is the Bat game. I wrote this one in Golang, and it's a simple shooting game. Each bat is a sprite animation, so it was fun to implement the logic to animate them. The bats sway around a little bit, and there's the illusion that some are further out than others. For every bat that you shoot down, the score increments. It renders a custom font to the screen, there's a crosshair, and there is some audio for the gunshots. I wanted to use Golang because it's the systems language that I'm most experienced with. Golang is mostly known for using with backend systems, microservices, command line interfaces, applications that don't have a native user interface. So I thought this would be kind of an interesting challenge. Also, Golang uses garbage collection, which in theory makes it unsuitable for real-time-ish applications, but I actually didn't have a problem with that. So for the library, again, I chose SDL2. There are Golang bindings for it. It was a pleasure to use Go. It's the type of language that just gets out of the way. You don't have to worry about memory management. You can still use pointers if you need to. Multi-threading is easy peasy, not that you really need it that much in game development. The only bump in the road was with the initial setup of SDL with the project. Since SDL is a C library and you're using bindings to access that API, the Go compiler had issues finding the SDL library. I actually had to hard code the path to the library file, so it was a little bumpy getting it up and running. Nonetheless, I think Go is a solid choice for games. I just don't know how it holds up with high performance situations. It's probably better to use Go for games that don't require really fast responsive input. So the cat game is probably one of my top favorite games in this whole series, actually. It's a side-scrolling game where you need to jump over the obstacles, which are randomly generated, and the scrolling increases in speed, so it becomes increasingly difficult. Now, I wrote this game in C++ because, well, C++ is the language of game development for the most part. It's got classes, multiple inheritance, abstract classes, both references and pointers, and all the tools that you need for game game development. A lot of these things you don't necessarily need to use, but they are useful. Also, C++ compilers don't really get in your way too much. You have the benefit of static analysis for type checks, but it's still going to give you the freedom to do potentially unsafe things, both accidentally and intentionally. The thing about C++ is that there's no single official dependency manager as far as I can tell, so getting comfortable with CMake is very helpful. It will automatically locate the compilers and the libraries on your system so you don't have to hard code them. This is great for cross-platform builds and collaboration. For the framework here, I chose SFML, which is very similar to SDL, but I would say it's more high level and actually a bit simpler. You can create a window, render graphics, handle input, play audio, handle all the fundamentals the same as SDL. However, one of the biggest differences is that SFML includes a sprite class. Typically, you would have a sprite atlas, which is a texture that combines all of your other textures into one big one. You need to somehow split this into multiple separate images for rendering. Well, with SFML, you can create a sprite object for each rectangular section of that atlas. Then when you draw these sprites directly to the screen, you can also scale and rotate them very easily. So it's a nice abstraction that can save you a lot of time. C++ as a language is solid, but it does get a bit annoying needing to use header files along with C++ files. Just seems a little bit redundant for modern programming, but it's not a deal breaker as long as you choose a good IDE to help you out. So this time around, I wanted to make a game for the browser because the browser is the most ubiquitous platform. Not everyone has a game console or a gaming PC, but just about everybody has a browser. Now, in terms of game mechanics, I wanted something along the lines of ice hockey, but more visually appealing, kind of like the Tron art style. How the game works is you click to create a vector, which determines the direction that the disk will launch. You can do this 3 times. Every time a disk bounces against a wall, then you get a point, but if any of the disks collide with another disk, then the game is over. It's all written in vanilla JavaScript using the Canvas API. Now, the Canvas API is natively supported by all major browsers. It's very simple to use in terms of drawing lines and shapes. Being in the browser, you can capture mouse and keyboard input the same way you normally would with event listeners. If anything, JavaScript is a very forgiving language that gives you a lot of freedom over how you want to do things. And JavaScript has evolved a lot over the years as well. JavaScript now has classes and inheritance, Canvas, WebGL. It's pretty powerful and it runs directly in the browser. The math for collision detection was a little different this time since we're dealing with circles rather than rectangles, but it wasn't rocket science. However, I will say that collision detection in general is trickier than it seems, because if an object is moving too quickly, then the game will be too late in detecting the collision. Then the object will just fly through the wall and disappear. So this next game also runs in the browser, but it's written in TypeScript and transpiled to JavaScript. The idea is to again draw a line that represents a direction and the ball will be launched in that direction. The goal is to figure out the optimal angle to launch the ball and get the most distance. Now, in this case, there was a big difference in how I handled rendering because now I included an actual camera system. So all the entities exist in world space and are rendered by converting their position to screen space. This created a much nicer and smoother experience because the camera lerps to keep the ball within the frame. This is some super basic stuff that a player just expects to be in a game, but it's not gonna magically happen unless the developer explicitly adds that into the game. Also, I included a texture for the bowling ball, so the game isn't just a bunch of primitive shapes. Handling rotation of the ball was not really a walk in the park because I wasn't that familiar with the OpenGL API. Basically, you have to translate to the origin of the object, perform the rotation, then translate back. You can see the shapes and the particles in the background. Those were generated procedurally, and I added that so that the motion of the camera is easier to notice. Ultimately, I really like this project, particularly because of the camera system. It's something you don't think about until you have to explicitly program it into the game, but it is a very important aspect of the game. But also was really educational in terms of thinking about world space versus screen space. So for this game, I wanted to make a clone of the Flappy Bird game. The game mechanic is pretty simple to program, so I decided to do it in C, which is a language that gives you very little in terms of structure and safety. No classes, no interfaces, no object-oriented programming built into the language. But because of that, it was definitely a good learning experience, because these constraints force you to solve code architecture in a different way. So instead of using classes with methods, you have structs and separate functions that are clearly meant to operate on that data type. Aside from that, I decided not to use a high-level framework like SDL or SFML, and to instead work with OpenGL directly, which was not a walk in the park. It requires you to think much more granularly and procedurally about how you are rendering things. For example, to draw a simple sprite, you need to specify each individual vertex of the rectangle to form a quad, then map the texture UV coordinates to each vertex. So once you've gone to hell and back just to render a sprite to the screen with OpenGL, you can rest assured that for the most part you won't need to go any more low level than that. I do like working with the C language, even though it doesn't have a lot of the features of modern languages, because it doesn't have so much abstraction. You can see what's going on line by line and not worry about what magic is happening under the hood, which makes for a very educational experience. So this one is the ghost game. I had this idea of being able to create a ghost of yourself. So basically you move around, and when you press the G button, it creates a ghost in your place. The ghost eventually fades away after some time. So what you can do is jump on the ghost, and this creates an interesting game mechanic that allows you to jump higher to reach obstacles. This game was written in C++, once again using the SDL library. I wanted to do a better job of handling collision detection because my previous implementations were not clean or efficient, so I gave it another shot this time. Basically, there's a single collision detector that iterates over all of the entities and checks if their boundary has collided with another entity. Then each entity is notified through their own method and can respond to that collision. This gives us the level of flexibility that we would expect in a modern game engine. I also added an event system because the player, which is an entity, needs to trigger the creation of the ghost entities when you press the G button. Then when the ghost fades away, it needs to then trigger the removal of that entity. So it's a simple event manager with a FIFO queue. All entities are able to push messages to the event manager. This creates a level of decoupling so you won't run into circular dependencies. So okay, I may have over-engineered it a bit, but the goal was to figure out better ways of handling common systems, and in that regard, I'm pretty happy. But I know there's always better ways to do things. This one is the helicopter game, and the goal is to avoid the obstacles. The player is a helicopter, and the physics tries to mimic the way a helicopter works. The direction that the blades are rotated is the direction that you go. So now we're dealing with rotation being an important part of the game mechanic. This one is written in Java using the LWJGL library, which is just Java bindings for OpenGL. I think Minecraft uses this as well. So it's essentially straight up OpenGL programming in Java. Now I'm really happy with this game. I have a soft spot in my heart for Java because Java is the first real typed language that I used professionally. If you have a good IDE like IntelliJ, then Java is very pleasant to use. With Java, you have the full power of object-oriented programming, classes, abstract classes, interfaces, private, public, methods, all that good stuff. So from a code standpoint, Java is pretty straightforward. However, there's a strangeness when working with native C code. Specifically, if you want to load textures, what I had to do was use a C library called STBI, which is commonly used for loading textures for OpenGL. Now, C doesn't have garbage collection like Java, so you need to use a memory stack to allocate variables on the stack to pass as arguments to the C function. But once you get past all that strangeness, it's not too bad. The only other thing that tripped me up a little bit was handling rotation. The update logic is simple. We create an up vector and rotate it by an angle. When the user presses the left or right key, then the angle changes, so the lift direction changes. The tricky part was in the rotation logic. You have to translate the object, rotate it, and then translate it back. Sounds familiar, right? This is exactly the same thing we encountered with the JavaScript game using the Canvas API. So it just goes to show that regardless of the language you use, you're definitely going to run into the same patterns over and over. Impulse is a mobile iOS game written in Objective-C. Now, I chose Objective-C because frankly, it's a language that always scared me a little bit. It's just strange and different than other languages. But what I realized is that it's ultimately just an object-oriented version of C. Now, the game mechanic is that there's a black hole that randomly appears at different parts of the screen, and objects will get sucked into that hole. More and more objects appear over time, and the goal is to tap on the objects to remove them until they all disappear. In terms of rendering, the game uses an Apple SDK called SpriteKit, which is a 2D graphics library that helps you render sprites and shapes to the screen. It also includes a physics system. So essentially, it's a game engine, which made this game a lot easier to make than the previous games. The black hole circles that kind of look like a radar, that was all rendered procedurally with code. The shapes spawned dynamically, and the high-level physics was managed with code, but the game engine handled the core physics behavior. Honestly, I do feel like I kind of cheated with this game because using the built-in physics engine, you just check the box and then it magically works. But at the end of the day, the player doesn't care as long as the game is fun. That's all that matters, right? It was pretty fun playing around with vectors and impulse forces to try to get the best result. So Jumper is a simple point and click game. The goal is to click the red box before it turns black. If you click in time, then it turns green, otherwise it stays black. So with this game, I did go back to the Rust language because I wanted to try out the game engine called Bevy. Now, Bevy claims to be a data-oriented game engine with an ECS, Entity Component System. The game itself is rather simple. I didn't want anything too complicated because the main goal here is to try out the Bevy game engine and see what the experience is like. I have to say, I really like it, and it restores my faith in Rust as a language for game development. So normally with Rust, you have to wrestle with the borrow checker and lifetime annotations, and it really sucks. But with Bevy, for some reason, I did not run into those issues. So at the high level, you can make your entire game a plugin module for the Bevy engine. Within the plugin, you have a builder function to add other plugins, resources, and systems. A resource is a global object. A system is literally just a function. You've got the startup system to handle the initial logic like setting up the world and spawning entities. Then you can add additional systems that will run on each iteration of the game loop. But again, a system is just a function, and I love the simplicity. Everything in Bevy is about components, not entities. Even when you spawn an entity, it's really just a collection of components. So you do have to wrap your head around that. The most impressive thing to me here is queries. Within each system, you can add multiple queries. A query allows you to get references to specific components so that you can do things with those components. You can just add a query as a parameter in your function and it magically injects it during runtime. One thing worth mentioning is that the Bevy engine uses a lot of macro magic, which means that your IDE might not be able to keep up and give you suggestions to autocomplete your code, which ironically makes it a little bit tougher. You might need to add explicit types in your code and not rely on the interpreter. Nonetheless, Bevy is a solid game engine if you are a Rust enthusiast. I do recommend giving it a shot, but only if you are comfortable with the Rust programming language already. So this one is the kitchen game, and it's all about choosing the right ingredients to make the dish. If you click all the right ingredients, then you pass, otherwise you fail. And there's a cool sort of witchcraft effect at the end of each round. So I'm personally not a big fan of games like this, which is why I considered it the perfect challenge. Because sometimes you gotta build things you don't wanna build, and you need to build them in a way that you don't wanna build them. I chose Python because it's a language that I've always avoided. Aside from popularity with machine learning, I'm not very fond of Python as a language. Python is not really known to be a safe language, nor a very performant language, but it does get the job done with minimal lines of code and is very easy to read. so it does have that going for it. Programming with Python doesn't feel like programming to me. It feels like scribbling notes on a piece of paper and hoping that everything works because there's no static analysis and everything is dynamic. But hey, nonetheless, you can make a game with Python. So in this case, I chose the Pygame framework, which uses SDL under the hood, but it provides a fairly high-level abstraction so you can painlessly just make your game. You can load an image with a single line of code. You can load up fonts to render text pretty easily. Pygame is a pleasant framework to use. I would recommend it for people who are starting out with game development. And if you already have programming chops, then it's a nice framework to build quick and dirty prototypes, but maybe not the best thing to use for commercial purposes. Writing a large-scale application in Python is possible, I just don't recommend it. So this one is the ladder game, and it's hardly a game, to be honest. You can go up and down ladders, and there is gravity if you fall. This is a proof of concept for a game mechanic. There are certain game mechanics that can present a programming challenge, like flying, swimming, climbing a ladder, being mounted to a moving object. So in this game, I wanted to implement the mechanic of walking around, jumping, and climbing a ladder. But I also wanted to do a programming experiment at the same time. Now, the application itself is a C++ program, but the business logic is written in Lua, which is a scripting language, and scripting languages can be interpreted and executed on the fly without compiling the code, which means you can have hot reloading of your code. So your game logic can update without needing to recompile and run the game. It is common for games and general applications to use some sort of extension language for writing plugins. So I wanted to create a plugin system here. In this case, I've got a few Lua scripts that are plugged in, one script to procedurally generate a level, and if I update this code, then the level is instantly updated according to the new code. I've got another script to control the player size, and another to control player movements. These are things that I may want to dynamically change during runtime. The Lua language is far from perfect. To me, it's a mix between JavaScript and PHP. It doesn't have normal arrays, it has associative arrays, but nonetheless, it's not a terrible language. Overall, the way that you bridge the C++ and Lua layers together is kind of rough to understand at first because there's a virtual stack that you push the arguments into before evoking the Lua function. Then after, you need to get the return values and pop them from the stack. It's quite low level, but it's not too difficult to implement. The thing is, from a performance standpoint, that's when it starts to suffer. It's not a great idea to evoke a Lua function inside of a hot loop, like the game loop, for example, because it's a lot of context switching and it can really degrade performance. But for operations that don't need to happen on every frame, I think it's worth giving a shot. I would love to try out Lua for AI behavior, scripting for cinematic scenes, and things like that. So this is where it started to look kind of nice. This is a game called Moody, and the gameplay mechanic is based off of a game called Geometry Dash. I wanted to incorporate music and rhythm into the game, and this is where it started to get exciting because I started making the games 3D as well as using game engines. So for this one, I didn't want to use Unity or Unreal Engine because those are the obvious choices, everybody uses those. So I chose Godot or Godot, however you want to say it, because it has a really passionate community and it's a more low-key game engine. Godot is a great free open source engine. The UI is surprisingly good for an open source project. It uses the GDScript language as well as C# and C++ apparently, but I stuck with GDScript, which is the standard way to go. It's similar to Python. What's great about it is the fact that there's some sort of static analysis where it does help you find errors in your code before you execute the game. So I'd say this is a great step above the Python experience. Like any other game engine, you can attach a script to an entity. There's a ready function and an update function, the bare bones stuff that you need, no object-oriented fluffiness. I really like how lightweight the Godot engine is. compared to Unity and Unreal, which will have you downloading gigabytes of data just for the editor. Godot, last time I checked, was less than 100 megabytes, and it includes a code editor built in. Also, Godot has a thing called CSG objects, which are shapes that you can combine to form more complex geometry. For people like me who are not great artists, this is amazing. Godot also has a rigid body physics system which works out of the box. Textures and lighting aren't too difficult to set up. For a basic 3D project, I think Godot is a solid game engine. My only major concern is the lack of mobile support. If your game goes viral, a lot of people love it, and you want to port it over to iOS and Android, that will be a lot easier to do with Unity or Unreal. Aside from that, I give Godot a solid 2 thumbs up. So for the letter N, the first thing I thought of was the word Nitro, which made me think of Need for Speed and race cars, but then I thought, well, I would have to implement the physics and the rotation of the tires and suspension, and that just sounded kind of crazy. So I thought, if I remove the tires, now I have a hover car. Now I'm pretty rusty with Blender, so don't laugh at me, but I was able to model something that vaguely resembles a hover car. The shiny material definitely added a nice look to it. For this project, I decided to use the Unity engine, which uses C# for the scripting language. Initially, I tried to handle the physics from scratch without using the rigid body component, meaning I wrote the code to explicitly set the velocity and position and rotation of the hover car. But I knew that going down that path would mean that collision detection would be a nightmare. So I tried again with the rigid body component and wrote some code to apply various forces based on input. But there's also some code that sort of balances the vehicle to keep it steady. There's 4 jets underneath the vehicle, and I use raycasting to figure out the distance from each jet to the ground. The closer the jet is to the ground, the stronger the push. As the distance increases, then it lets off the gas, so to speak. But to be honest, this logic is far from perfect, so I kind of cheated. Basically, the collision area around the model actually extends below the model, so the entire entity still mostly hovers above the ground, but every once in a while it'll collide with the ground. However, since the mesh is elevated, it doesn't really look like it touches the ground. Obviously, there are drawbacks to this approach, but I didn't want to go down the rabbit hole of doing literal rocket science. It would be cool for a more serious project to continue to improve on the code and handle more nuanced situations. Overall, I'm pretty stoked about how it visually turned out. With the post-processing, the motion blur, and the smoothness of the camera, it turned out to look pretty dope, to say the least. So hey, before I talk about the next game, please don't forget to like and subscribe, leave a comment below. This is going to help the algorithm find me, and then I'll be really happy and make a bunch of videos. Thank you for watching. At some point, I wanted to start working with shaders, but I also wanted to play around with 3D rendering in the browser, so I chose to start a WebGL project. So I chose to use a library called THREE.js. It's a wrapper for the WebGL API that helps you easily render 3D in the browser. So by using THREE.js, I could focus less on building a rendering pipeline and more on just creating a custom material shader. I'm really impressed by this THREE.js library. I was able to easily place objects in the world, rotate and scale them. I was also able to import the rock model that I made in Blender. It uses the GLB format, which is like the official OpenGL standard for 3D models, particularly over web. Then I found a nice texture for ice, and with a little bit of shader magic, I got the ice rocks to show up. But this isn't the only way to use shaders. It's actually pretty useful if you want to create a special effect. So I played around with some numbers in the fragment shader and got this really cool vignette effect that only applies to the rock material. Shaders are awesome because they give you low-level control over the geometry through the vertex shader and the individual pixels through the fragment shader. You can literally control every pixel of that material and how it renders based on camera position and lighting. Right now, I'm a complete noob when it comes to writing shaders, but it's definitely an area I want to get good at, because shaders can take something that looks boring and flat and make it look shiny and amazing. And the fact that we can use real physics formulas to mimic the way light reflects off of a surface is actually pretty crazy if you think about it. For this one, I wanted to make a fighting game because I've always been a big fan of Mortal Kombat and Soul Calibur, and a fighting game is sufficiently different from a shooting game or a racing game. For example, the movement and camera system is constrained to mostly 2 dimensions, and usually you have a strong attack, a weak attack, and you can block. So I jumped into Mixamo, grabbed a model of a ninja, and imported it into Unreal Engine 4. Despite me being rusty with Unreal Engine, it wasn't too difficult to get the animation blueprint working with the Mixamo animation. But I will say that the blueprint can get pretty verbose if you're mapping the transitions. I chose to use C++ for the parent blueprints because I generally like C++ for game development, and it's something I wanted to get comfortable with in the context of Unreal Engine. I found that when it came to having good control over animations, I needed to track the walking velocity, the progress of the attack animation, and the distance where each attack should land and cause damage. Having a single shared class used by both the player and the AI was super helpful because I didn't have to rewrite the same logic twice. The AI is actually ridiculously basic. It just slowly walks towards you, and then if you're within range, it'll punch you every few seconds. This was a fun game to make and definitely enlightened me on a few things. For example, you would probably want to mirror the animation so that the character's front side always faces the camera. You need to consider that the player may not always be on the left side. One thing I would do next time is add some impact to each hit and have the victim get pushed back a little bit. Overall, I think I would want to make a serious fighting game. I think there's a lot of potential for doing something unconventional in that genre. For the letter Q, the first thing I thought of was the word queen, which made me think of knights in armors and castles and archers with bow and arrow, and I was feeling inspired, so I jumped into Blender and started modeling. This was by far one of the most fun parts of the project because it was like visual programming. I used to hate 3D modeling because I thought you had to work one polygon at a time, but using the Blender modifiers makes everything much faster, easier, and non-destructive. I'm not saying that the model turned out great, but it's something. Next, I needed a character model with animations. I found the perfect model on Mixamo, and after a few minor hiccups, got it imported and working nicely in Unity. I imported the castle, then added terrain, and got the environment looking halfway decent. Then it was time to add some real gameplay mechanics. I first started with AI for the NPCs. I experimented with having the NPCs running around in a bounding box, but in reality there was just no reason to limit the area to the bounding box. There was also no good reason to make the NPCs randomly run around at all. Ultimately, I settled on using a state machine for the NPCs. At any given time, the NPC is either idle, changing position, or attacking. For the most part, Unity does take care of the heavy lifting and handling animations and transitions with minimal code, but a good chunk of the code was related to animation. I needed to know when a particular animation started and ended, but I couldn't figure out the proper Unity way of doing it in a clean way that I was happy with. So I chose a brute force approach, keeping track in code when the attack started and when the arrow would be released. In the end, I was happy with the results, even though the solution was a bit hacky. For the player camera, I actually chose to code it from scratch because I wanted to get comfortable with rotation logic, radians, degrees, sine, cosine, tangent. It can get a bit confusing, but it's good to understand that stuff. So with this game, I was getting more into the groove of using 3D game engines and creating cameras and animations and all that good stuff. It was a little rough around the edges, but it was a good start. So this one is a racing game, and I chose Unreal Engine 5 because I wanted to use the latest and greatest out there right now. Now, I'm not gonna lie, this was a little bit intimidating because my understanding is that to implement realistic physics for a car, you need to consider the nuanced aspects like suspension, the tilt of the body as the car turns, the subtle jerking of the pitch when the gear is shifted. But Unreal Engine 5 has a physics framework called Chaos Vehicles. This feature was highlighted in the Matrix demo. Chaos Vehicles is a system of blueprints and animation logic that pretty much takes care of everything you need to implement a wheeled vehicle. There are a number of steps required, from rigging the model with proper bone structure, importing that into Unreal Engine, and setting up the blueprints. But I didn't have to write a single line of code. You just have to be very careful with the rigging process and the units of measurement. For example, with Blender, you have to scale everything 100 times because 1 meter in Blender is 1 centimeter in Unreal Engine. In the end, I was really impressed by how well the animation came out, considering I wrote 0 lines of code. It handles the roll and the pitch of the vehicle. You can oversteer and understeer, and everything just looks nice. This next one is another Unity game, and I wanted to implement sword combat. This game taught me a lot about animation in the context of melee combat. The previous game, called Punch, was 2D combat, while this one is 3D combat. I was able to really lean on the Unity animator system, but I did have to do some grunt work on the programming side as well. Firstly, I used a blend tree for the run animations. This allows us to smoothly run and strafe in 8 different directions, very similar to Unreal Engine actually. The thing that really helped me was using multiple animation layers. The base layer applies a mask to the legs for movement, while the attack layer applies a mask to the upper body for melee attack. What this means is that you can attack while you're running in any direction. As a player, it's like, well, yeah, duh, you should be able to run in any direction and attack. But as a developer, you have to explicitly program that into the game. As for dealing damage, there's a sphere collider in the front of the character, and we simply check if the enemy is within range of that collider. But we also check to make sure that damage can only be dealt within a certain window of time, about halfway into the attack animation. When the character is attacked, they become stunned for a second and immobilized. In terms of the AI, it just chases you around and attacks you every 3 seconds. Overall, I'm happy with the results on this one. I spent 1 day on it and the code quality wasn't great, but again, good learning experience and kind of a fun little game to play around with. It was pretty common in some older games to put the player on a train. I've seen this in Final Fantasy VII, Half-Life, Gears of War, Hitman, Red Dead Redemption. Usually the train travels in a loop or for a fight sequence that can last indefinitely. Previously, I saw a video from a VFX artist who showed an interesting technique for making it appear like a car was moving on a highway. So I wanted to use this technique for a train sequence. For the inside of the train, it looks perfectly normal, like a train traveling over a foggy lake. The fog actually helps a lot with this illusion. But if I step out of the train and step back far enough, you can see that it's actually the train tracks that are moving underneath the cabin. But the cabin does rotate, and it actually works nicely with the dynamic lighting that shines through the windows and gives you some visual indication that you're changing direction. This was also a great example of using the Unreal Engine blueprint system to procedurally generate the train track geometry along a spline path using instant static meshes to drastically improve the performance. If there's one thing this project has taught me, it's that GPUs are not really as powerful as we think they are. Now, I'm using an RTX 3080, and if you render just 100 cubes on the screen with no complex shaders, your frame rate is going to drop really badly, even if you were on an RTX 5090. So you need to use instant static meshes, which basically bundles together the drawing operations for the GPU. Basically, optimization is a really big factor in game development, even early on in the process. I've always been a big fan of sci-fi and space travel. So for this game, I wanted to control a ship in space and shoot other ships. Now, originally the environment was supposed to be in space. I bought an $8 asset bundle with skyboxes for space, but space is actually boring. From a lighting standpoint, it can be tough to find enemies without a heads-up display. So the more interesting visual is when you're on a planet, low enough to be in the atmosphere, yet high enough to be out in space. This is actually the default Unreal Engine background material that I'm using for the skybox. I added a big sphere back there that looks like a moon. It looks a lot bigger than it actually is. Everything here is real geometry, so the lighting is consistent for all objects, which is one reason that it looks nice. The asteroid belts are generated procedurally with the C++ blueprint. The script creates thousands of static mesh instances along a spline, and I can adjust the shape of the spline to instantly regenerate the objects in the editor. As I talked about before in the train project, using instant static meshes, that's a tongue twister, is really important for performance when you're rendering a large number of objects. To me, this is definitely the highlight of the project. The fact that you can render so many meshes with very little impact on performance is kind of crazy. As for the spaceships, I grabbed some awesome 3D assets from TurboSquid. For the movement system, I used a component called Floating Pawn Movement, which is nice because it has built-in constraints for maximum speed, acceleration. For the AI, they basically just move to a random location near you and every few seconds try to attack you as well. And when you destroy enemies, they explode. Overall, this is easily one of my favorite projects in terms of the visuals and just the fact that it's sci-fi. So the letter V is for violence. This is a first-person shooter game, and it's actually the first-person shooter game I've ever tried to make. I always had an idea of how I might make one, but I never actually did it until now. And I chose to use Unreal Engine 5 because I thought it would look visually impressive. Don't get me wrong, I love first-person shooter games. Quake 3 Arena, that's the OG. Doom, Half-Life, Call of Duty, Battlefield, those are all awesome. But the FPS genre is heavily saturated, which makes it kind of intimidating as an indie developer trying to crack into that genre. That's why I was reluctant to make an FPS game, but here it is, I gave it a shot. So for the movement system, I used the built-in character controller, which is great for automatically handling collision detection, running, jumping, crouching, and just about anything in regards to movement. But for the gun, I implemented that pretty much from scratch with code. I took a model from TurboSquid, modified it in Blender to split it into two parts. I used blueprints to handle basic input, then feed those inputs into a C++ class. So the code handles just about everything about the weapon, including rotation of the muzzle, the sway and the recoil, bullet holes, explosion particles, and bullet trails. There's also a nuance when it comes to making the gun feel impactful. You need to make the enemies respond to those bullets. I focused a lot on character animations and AI. For the enemy animations, I used a blend space so the enemies don't just run straight forward, but they also strafe to the side and walk backwards and all that. The animations use a mask for the upper body and lower body, similar to Unity, so that the enemies can run around and crouch while shooting you. The enemies react to being hit while moving, and they sometimes crouch. The enemies basically just find a random position within a certain radius of your location and go to that position, but they can shoot at you while they're moving or crouching. All of the AI logic was done in C++. The big challenge with this project is simply keeping track of all the little things that needed to be done. When there's 100 things you need to do, it's easy to forget some things, like the fact that you should have bullet holes and the enemy needs a death animation. A matter of fact, I almost forgot to even give enemies a weapon. At first they were just standing there with empty hands, and I was like, hey, this looks good. So yeah, this was a cool game. It was my first foray into creating a first-person shooter game, and I really started to see all the nuance that goes into the animation of the weapon. Like, even though it's just an inanimate object, a big clunk of metal, there's a lot of things you can do with that clunk of metal. So for this one, I wanted to mimic the look and feel of Warcraft, and I say that very loosely, literally just having a top-down camera system, a 3D cursor, and multiplayer. I'm not a very creative person, so procedural generation is something I wanted to focus on more as a tool for easily and rapidly creating levels. I'm a big fan of non-destructive editing, so same as I did for the space game and the train game, I used a blueprint to procedurally generate a rocky wall as well as a fence to guide the player. Unreal Engine has this cool feature where you can sculpt the landscape non-destructively using layers and splines. I've also made a blueprint where I can spawn any arbitrary object along points on the spline, which saves a lot of time not needing to manually place objects around the map. Multiplayer is something I've never implemented before, but it turns out with Unreal Engine, it's actually very easy to enable multiplayer. It's just tricky to get it working properly. If you're just hacking things together your own way and not following the framework, it's not gonna work. You need to decide early on if you want to have multiplayer in the game because it is gonna influence the architecture of your code and blueprints. You need to keep track of things and do things the Unreal way for multiplayer to work. There are a few things I initially did wrong. For example, the camera needs to be part of the player character and not an independent entity. Rotations need to be applied to the player controller and not the player actor. Most importantly, you need to determine what logic will be handled by the client side versus the server side so that everything syncs up properly. Otherwise, each player will see their own different version of the world. Sometimes events are evoked on the server and replicated across all clients. For example, when the boxes spawn in the level, the boxes are only spawned on the server, then replicated so that all clients can see them. Since the box is owned by the server, the clients cannot directly interact with it, but the clients can indirectly interact with it through the server. The server always maintains authority over the state of the game. When it comes to rendering, for example, the bullet streak particle effects, that is a client-side function that gets replicated through the server to all other clients. So at the end of the day, because of all of this, multiplayer is not something you could just tack on to a single player game. You need to decide early on that you want to have multiplayer. So up until this point, I had focused mostly on game mechanics, and now I wanted to make something more cinematic. There's a scene from the movie Mission Impossible Fallout where Tom Cruise jumps off of the back of an airplane, and I guess they call that a halo jump. And I thought it was really cool, and I wanted to sort of mimic that in a game. And so I used that as a reference to make a cinematic cutscene. At first I was going to use Unreal Engine 5 because I really wanted this to look as good as possible, but then I thought, well, let's see if it works out in Unity. So I used the classic military character from Mixamo, which is a really solid 3D model, by the way. From there, I added some city lights at the bottom and a decent nighttime skybox. Now it started looking decent, but something was missing, so I added volumetric clouds with a script that I bought from the Unity asset store. I added a helicopter as well, so that at least you know where this guy came from, and it adds some verticality to the clip. The overall motion of the sequence was created manually in the Unity timeline, but there are a few different scripts that add procedural characteristics on top of that. For one, there's camera shake, which is procedurally applied and customizable. There's autofocus, since the camera uses depth of field. And once the sequence is over, then it smoothly transitions into gameplay. This is where it really got exciting for me. The third-person aiming system uses inverse kinematics for the arm, which basically applies rotation to each of the bones of the arm and spine with different weights to make them point towards the enemy. For example, the shoulder, arm, and hand should point directly at the enemy, so we use a weight of 1. On the other hand, the spine is going to very slightly lean in that direction, so we use a much smaller weight. Ultimately, this all helps to make it so that the character doesn't feel so rigid like a robot. For me, the procedural animation side of things was really exciting because if you pull it off well, it just makes a game look nice and polished. At the end of the day, I'm pretty happy about how all these elements came together to make a really fluid cinematic experience. And then afterwards, you can actually transition into gameplay and then shoot the enemies down, which is pretty fun too. So this is the second to last game, the letter Y, the Yacht game. And this is where I wanted to make a boat that fluidly moves on water. So water is a very fluid thing. You can't just have your boat sit there stationary on the water. The main thing I wanted to capture was the swaying back and forth to make it really feel like you're in the ocean. For this one, I chose Unity because I was getting a little too attached to Unreal Engine, and I want to show Unity some more love and not be too biased against the game engine. So when I first tried to implement the boat movement system, I tried using a rigid body component, which was not kinematic, so it would simulate physics. I found this to be very difficult to control. Once an object builds enough momentum, it's difficult to control the object. So I made the rigid body kinematic so that I would have complete control over rotation and movement. The downside to this approach is that you have to completely control the rotation and movement. So rather than treating this like a physics problem, translating forces into motion, instead I treated it like an animation problem, combining different motions together. First, I wanted to focus on rotation because with rotations, you have to use quaternions, and quaternions have always been kind of scary to me, so it's something I wanted to tackle head on. The first thing I added was the sway of the boat. Anytime there's a circular motion in the game, I just throw sine and cosine at the problem, and that's usually the solution. After that, steering was implemented by updating the yaw rotation, and when you steer, the boat should also tilt in that direction that you're going, so I added some roll based on the yaw velocity. The big thing I learned about quaternions is that if you want to combine the effect of multiple rotations, you just multiply the quaternions together, but order does matter. Then it was time to make the boat actually move around. This part is the classic where you just increase the velocity over time and then you apply the velocity to the position on each frame. But the last subtle thing I wanted to implement was pitch, because when a vehicle accelerates, the front side tends to tilt upwards, and when the vehicle slows down, the opposite happens. So I tracked the acceleration and applied pitch based on acceleration. One thing I didn't consider up until this point was collision detection, and basically collision detection does not work if you're using kinematic physics. The boat doesn't simulate physics. So I added some logic that detects if the boat is touching another object, and if so, it temporarily disables the kinematic mode and simulates physics. Then once the boat has stopped touching the object, it goes back into kinematic mode. It's not a perfect solution, but it does handle collisions pretty decently. In the end, I like this project because it was a little bit different. You're not attacking anybody or punching anybody. You're just chilling on the ocean and swaying to the waves of the ocean. And yeah, pretty happy with this project. So now we're at the last game, number 26, letter Z. This one's the big boy, the banger. This is where I wanted to combine all of the lessons that I learned from the previous games to ultimately try to build a AAA quality game experience. Now, because there's so much to talk about with this game, I'm actually going to talk about it in my next video. Don't worry, I already prepared the content, already wrote the notes and everything. That video is going to come very soon, but I think it's worthy of having its own video, and that's why I want to split that into a different video. Anyway, as usual, it's Ryan here. I hope you enjoyed this one. I hope you learned something. Thank you for watching. Thank you for supporting me. Again, please like and subscribe, leave a comment, support a little YouTuber like myself. I want to continue making content for you all. Thank you for watching and have a nice day.